Subscribe to get wow videos and press the notification button so that you can never miss any video. Assalamualaikum friends. How are you? Fine? Yeah, that's great. So today I came up with the topic of pre-stressing beams or girder. How to design pre-stressed beam and girders. So without wasting any time, let's move to the software. So here I am opening SAP2000. So here is this interface. So first I am going to open a beam model to define a new. First I am changing the unit to kip feet and selecting beam. So let's, for example, I'm doing it as example purposes. So let's, for example, I have a single beam with a beam with a span, have only one span, and its span length is about, you can say, is 30 feet, right? Press OK. So here is beam is defined. So now let's define a cross-section area for this beam. So what we will do, we will first go to the define and go to define materials. And in define material I have 4000 psi and this steel bars. So what I'm going to do, I'm just first moving into 4000 psi of concrete and modifying some of its properties. So let me just first change it. I want to change it into first, let's suppose I'm just changing it into 6000 psi of concrete, and here I want to change the elasticity modulus. It's totally up to you. You can change and you can choose whatever you want. So I'm just moving it to, let's suppose, 4400 of KSI, and I'm just moving this concrete to 6000 PSI or 6 KSI. So that's okay. You can change any other thing over here according to your desire and according to your, I must say, according to your requirements. So press OK. Look, it has been changed into 6000 psi. Now here I need to define another material, and this material should be tendon. I need tendon over here, and basically what is this tendon? Tendon is a bar which we use in this beam to pre-tension it, right? So what is its elastic modulusity? I'm keeping it same, and let's just keep this value. Let's its minimum yield stress is 216 and 250, but we can change it to any value. So we can keep it to 70 and then keeping it as 1.1 times of 270, right? And press OK, and OK over here again. The next thing is I need to define the material properties. So first I'm going to frame section, and here I'm adding a new property of concrete of rectangular, and let me just take it as a depth, take it as a 30 inches, sorry, so it becomes 2.5 feet, and width of 1.5 feet. You can define any number according to your desire and just rename it into beam. And similarly here in concrete reinforcement you need it to check as it beam. So it's beam with the material of 6000 KSI. That's okay over here, and that's okay. Now you need to go to define section properties and into the tendon sections. Here you need to define a section for the tendon. Add new tendon. So it just picked at tendon 1, and yeah, I do need to apply this tendon as a load, and you can apply it as elements as well, and then no other specific changes, and press OK. You can change it according to your requirements. So press OK and OK. So tendon 1 is defined. Now the next thing is we need to define the load combinations, and here I need first let me define load patterns. So here I am defining as a dead load pattern. The next thing I am defining is that a live load pattern. So keeping it live and adding it. And now the third is I am applying the pre-stressing. Pre-stress. I am defining load stress and pre-stressing and keeping the type as other and adding it. So press OK. I have defined, and now I need to define the load combinations. In load combination I am defining new, and let me just name it as wow. Right? So here you need to add all of these cases. So first I am adding dead, live and pre-stress. Keep all these scale factor as 1, because in the case of pre-stressing we normally know the exact load. Like we use pre-stressing in bridges and we know the exact load of the structure over the exact load on the structure. So nothing, any changes. So press OK over here and OK again over here. Now next thing is you need to assign. You need to select this and go to assign and go to frame and go to frame section, and you need to assign beam to it, right? And finally you need to insert tendon in this frame. So for that, click on this thing, draw frame, and from here to the, instead of straight frame, select tendon. So as soon as you select the tendon, here 10.1 is coming, which we have already defined here. So now what you need to do, you need to click over here and click over here. So as soon as you click on the both the location, a window will pop up. This window will pop up. Now you need to make some changes over here. You have to go to this parabolic calculator, and here you need to keep it as 1 and click on the quick start. So as you clicked on the quick start, you see this black tendon has been inserted, and by default it's inserted at 1 feet, and you can change it to any units from here. Let me change it into kpinch feet. So refresh it. So what does it do? It just defined a tendon which is 12 inches above from this and 12 inches below from this point and 12 inches above from this point. So what we need to do, we can define here our own values. Like if you want to keep it on 8 inches, so press 8 over here, it will just move down, and I want to keep it up to 3 inches. Let's suppose I want to keep this end corner 3 inches above from the main centroidal axis. So press 3 over here and press OK. Now if you just refresh your view, so you can see, if I just keep my pointer over here, it will show me, look in this corner, coordinate corner 1. You have to concentrate over here in this position when I keep this mouse over here. So 0 and 8. This 8 showing that this is on 0 point, it's moved up to the 8 position. So that's fine. So now the next thing is you need to click done over here, and here in tendon section you have to select tendon 1, and now in tendon loads I need to add the tendon load, and in tendon load I want to add tendon load which is under the pre-stressing load pattern name. So select pre-stress load pattern name and add the load. So let's, in my case I am keeping it as 200 kp of the force. So I am applying 200 kp force to this tendon to pre-stress my beam. So these are some coefficients. Now if you have some errors or if you have some uncertainties, you can pick these coefficients from one of the guide which we have from ICI or STM, but in our case we assume that our structure is completely fine. So keep all these coefficient as 0, right? So we are just working it in under the ideal situation, so no need to change anything. So press OK again, and all the other thing has been done. So press OK again. So look, your tendon has been inserted in the beam. So now what you have to do, I need yeah I need to assign the load to this structure. So select this, don't select the tendon. So select your beam, go to assign, go to frame load and assign your load. So under that load, let's suppose I am applying 2.2 kips per foot, pressing OK. So 2.2 kip, and on the same frame I am assigning some live load as well. So you can assign these load according to your demand. So let's suppose I am having 1.5 kip per foot of live. So if I just check it under the loads column, you can see dead load is assigned and live load is assigned. So now as we are all done with our loading and tendon, so we need to define that in how much section it should analyze our frame or it should analyze our beam. So I'm just selecting the beam and going to assign in frames and in output stations. In output stations, here it's by default is 9, so let's keep it 9 and see under 9 section how does it perform. Pressing OK. So look, it's defined as 9 section has been defined in this beam. So now what we need to do, we need to analyze it. So first analyzing, setting the analysis option and then running it. Our analysis is done. So now if you see that it analyzes our frame into the 9 parts, 1 2 3 4 5 6 7 8 and 9. So it analyzes our frame in 9 parts, and you can see the demand is 279.72. I just unlock the model now and I select this frame. And go to assign and go to frames and go to output station. Now if I just increase this from 9 to let's suppose 30 and see what happens. Now he is dividing my frames into 30 sections, and now just I'm running it. Yeah, now if you see, the moment demand has been increased to 282.16 and location is also somewhat shifted from the previous one. So previous one will be 279 and this is 282. So you can see that how the difference is coming in the values. So output stations are much helpful in accurately analyzing the structure. So now the final thing I'm showing to you. So this is the behavior of the beam while we have tendon installed in it. So what if we just unlock the model now? So now what if we just remove this tendon, select the tendon and press the delete button. So now if you just analyze it under the same conditions, so you will see, yeah, now if you see, the moment demand has increased to 479, almost 480 kip per kip feet of the moment. So you see, while using the tendon, while using the pre-stressing technique, we can reduce the moment demand. So that is the basic purpose of the tendon. So in first case, if when we analyzes it, it was 279, and then second case, if we then we increase the number of frames, it jumped up to the 282, and now if we just remove the tendon, it just goes almost double, 478. So you see, by inserting the tendon, our moment demand is going to decrease. So that is the advantage of pre-stressing. Almost got it. Yeah, so down in the comment section, tell me that this is useful for you or not. So let's conclude our lecture, and so right now it's time for you to respond to me in the form of subscribe, likes and share. So press that red button in the right corner, in the right bottom corner, so that you can receive my videos without any difficulty. So see you in the next video. Thank you.